Hey Spring fans! In today's installment of Spring Tips, we're going to look at how to build complex integration flows and stream processing solutions using Spring Cloud Dataflow. In previous videos, we looked at Spring integration as a way of building messaging-based and event-based systems by integrating systems in terms of events. And then we looked at how data flows from one node to another in terms of channels. We then, in a subsequent video, looked at how to build messaging-based microservices using Spring Cloud Stream. Spring Cloud Stream builds on Spring integration, and it alleviates the need to specify the tedious sort of adapters, the inbound and outbound channels that we use in Spring integration are still there, but we don't have to worry about how these things talk to other nodes, to other services. That connectivity is commoditized. It's executed into a configuration file, and the rest of it is sort of applied and based on convention. So we get the result of systems that talk to each other, but we sort of commoditize the transport, and we do that using what's called a Spring Cloud Stream binder. There are several binders out there, notably RabbitMQ and Apache Kafka. So you can build Spring Cloud Stream based services, microservices that talk to each other using Spring Cloud Stream RabbitMQ or Spring Cloud Stream Apache Kafka, and we can just write code in terms of generic Spring integration channels, none the wiser or none the more aware of these underlying components. Today we're going to look at something called Spring Cloud Dataflow. Spring Cloud Dataflow is a way of choreographing microservices based on Spring Cloud Stream, modules based on Spring Cloud Stream. These modules accept data, produce data, and sometimes optionally both accept and produce data. And Spring Cloud Dataflow rewrites, or it sort of provides the configuration for the incoming channel and for the outbound channel. So really the only requirement to use your Spring Cloud Stream module in Spring Cloud Dataflow is that it produce messages, if it's going to produce messages, on a well-known message channel called output, and that it accepts messages, if it's going to accept messages, on a well-known channel called input. Spring Cloud Dataflow then, it stores the state for those descriptions. It knows about the location of different Spring Cloud Stream modules, either in terms of a Maven repository or a Docker image or something like this. And then you provide a DSL. You provide a description of the composition of these different components in terms of what's called a stream. So again, a stream is an infinite, unending sort of thing that handles data in a potentially perpetual way. A task is something different, right? A task is something that handles a finite amount of data. A batch job, for example, is a finite amount of data. Spring Cloud Dataflow can manage and sort of choreograph both tasks and streams. Your task might, for example, be a Spring Batch job that you want managed and sort of administrable from a single place. So the Spring Cloud Dataflow service does this for you. It's a service that keeps its state in the database. You can then, as an operator, go to that server and then use it to manipulate or sort of monitor these streams and tasks. So let's go do that. I've got an FTP server running, and you may recall in the Spring integration video we built a simple solution that took data from an FTP directory, and then we wrote it out to an FTP server. Lots of very, very simple sort of transformations. And today we'll do the same thing with even less code, with even less sort of cognitive overhead. We'll do that using Dataflow. Now, Dataflow, as I say, is agnostic about the underlying distribution mechanism. Remember, it's going to orchestrate or choreograph rather your different services on a distributed topology, something like Cloud Foundry or Mesos or Yarn or whatever, right? So we're going to go ahead and say Dataflow service, and I'll bring in the local Dataflow server here, and that's it. Now, of course, we could provide a H2 data source if we wanted to, or some other data source, but it's already got an in-memory embedded in H2 data source, so it'll work just fine. Let's go ahead and hit generate. Open this up in our IDE. It doesn't really matter which IDE. And now we do as we always do with a sort of Spring Boot based service these days. We add an annotation, and the auto configuration does the rest. So we can spin it up on port 9393, good quality ASCII artwork. I think you'll notice that first and foremost when the application starts up. And then, of course, the application itself is up and running, and it is a fairly sophisticated API, but it's already written for us, so that's an API we don't have to worry about. So we go here now to localhost 9393, and you can see this is the hypermedia or HotOS REST endpoints. These are the endpoints for the API itself. You don't have to use this API directly for the furthest thing from it, right? We can use the dashboard. So here, I go to the dashboard, and you can see I've got several options here. I can get information about the server itself. I can look at the analytics for counters and things like this. We'll come back to that in a bit. I can look at the ongoing sort of jobs that are running. Right, this is a drill down of Spring Batch jobs in particular. I can look at the tasks. This is the overarching concept called a task, and that might include Spring Batch jobs, for example. And then I can of course look at the streams, which we're going to create in a minute, and the runtime. Now the runtime refers to the components that are available, the Spring Cloud Stream apps and tasks that are available for use, right? That are running somewhere. In this case, on our local machine. And the apps refers to the modules, the jars in this case, or the Docker images or whatever that are available for use for composition into complex solutions. I can register a new application by providing a name, the type of component, and a URL. In this case, maybe a Maven URL, something like Maven IO, Spring, etc., etc., etc. And that would even resolve on your local Maven repository, or you could specify a repository that you want to use instead. But what I want to do is I want to bulk import some of the existing Lego bricks that are provided by Spring Cloud Dataflow. And I can do that by going to the bulk import applications, and I can see here there's 4 sets of pre-configured stream applications and 2 sets of pre-configured task applications. The streams are divided both in terms of the type of binder, RabbitMQ or Apache Kafka, and the format, whether it's a Docker image or a jar, right? It knows how to deploy and execute both. So we're going to go ahead and bulk import all of the RabbitMQ-based Maven coordinates for all the existing jars. So again, this refers to just a litany of different jars that contain Spring Cloud Stream applications, or Spring Boot applications, really. When Spring Cloud Dataflow uses those stream modules, it's just going to start them up, right? That's what we mean. It's going to deploy them. So now if we go to apps, we can see all the different components. And in the output here, we can see specifically that there are 3 main kind of components reflected here. There are files, or rather sources, which produce a message on a well-known channel called output. There are processors, which take a message in on a well-known input channel and then write a message out on a well-known output channel. And then there are syncs, which take that in on a well-known input channel, right? So these are Spring Cloud Stream modules, one and all. The only convention required for them to be usable as a source or a processor or as a sync is that they expose a Spring Cloud Stream channel called output and input, or sometimes both in the case of the processors. So now we've got these apps. Let's go ahead and build a stream out of it. So we're going to go to the Streams tab, and here we can see that we have no existing stream definitions. Let's go ahead and create one. We're going to use this visual editor, which supports input as in one of 2 different ways. We can do it using the Spring Cloud Dataflow DSL, or we can use the visual way to do it. So let's start with the DSL. The DSL matches or looks very familiar to anybody who's ever used Bash. So I'm going to say that we want to take data from the file source and write it to the FTP sync. The FTP sync needs some information about where to put the files naturally, right? This is going to be, ultimately it's going to be a running Java process running somewhere, and so we can provide parameters that get passed to that running process, and the same way we would any other Spring Boot application, as -d arguments, as environment variables, as whatever. In this case, it's more convenient to provide them as part of the definition here. So ftp.factory.host equals localhost, right? We can copy and paste some of these values to go a little faster. So ftp.password equals spring, ftp.username equals jlong, ftp.port equals 2121, and so on. We can do this certainly, and the visual tool is aware of them, but we can also edit these properties visually, right? So we can click on the little gear icon there, and we can specify, for example, that we want whatever files appear in the directory that we're going to monitor to be split up and published as separate messages for each line. That's called the lines mode. We can specify that we want to monitor the directory called in on my desktop here, and then we want to monitor only files of type .txt, and then we want to prevent duplicates. So I think everything else looks fine. We also want to specify information about the FTP server itself. So I want to automatically create the directory in the FTP server if it doesn't exist. I want to use a temporary file name, absolutely. And I want to use an expression to arrive at the name itself. So I'll say tmath.random headers.file name. So what's going to happen is it's going to take the incoming messages, which are going to be provided by or produced from our file source and the Spring Integration inbound file adapter, and it's going to contain headers, in particular a header called file name, and normally it would use that file name to write the file to the FTP server. So if I put a file called foo.txt in the in directory, it would get uploaded to the FTP server as in.txt. But in this case, I'm going to divide that in.txt by line. So I need to make sure that even if multiple messages come in with the same file name, that we differentiate them, right? We don't want them to all overwrite each other. So we're going to use an expression, a Spring expression language expression, to provide a random number and then the name of the file that we originally had. Okay. There we are. Now you can see that the UI here is having a little bit of trouble with the Spring expression language statement. No problem. We just encode it and everything seems to sort itself out. Now this is certainly interesting enough, but this is all we managed to do last time. Let's go for a little bit more interesting solution. So what if we could take the lines that are going to be produced from the file source and then automatically capitalize them using a processor, a transformer in particular. So let's go ahead and insert that into the flow by disconnecting this this component to that and then connect it instead to this and to that. So now if we look at file, mode is lines, the directory is the same, text is the same, everything is basically the same, but we have to provide a transformer, and what this is expecting is a Spring expression language statement. So we'll say payload.toUpperCase, for example. Hit OK, and our FTP component is going to work the same as well. So everything is as we expect. I can also imagine wanting to log the data that comes out of this transformer, or indeed the file source. So in this case, we can use something called a tap. A tap is a way of taking the data from a message producing component, that is to say a source or a processor, but not a sink, and then diverting it to some other component, for example, a logging sink. So we can do that by grabbing the tap port here and connecting it to the log, like that. Okay, so there we are. There's our slightly more sophisticated definition. You can see that Spring Cloud Dataflow and Spring Cloud and Spring Flow have given our stream definitions names for us, and it's used that name to describe the tap here. So we're saying from the component called transform in the stream called stream1, divert the information to the log component, right? The log component. And again, you can specify the levels, for example. We can specify some sort of expression to transform the data, whatever we want, right? All right, so there we are. There's our simple definition. Let's go ahead and create that stream, or those streams even. And we're going to call this files to FTP, and we're going to call this line to log. And when we deploy, when we create the definitions, we may as well, in the same swoop and the same sort of go, also deploy them. So let's get create. It's going to go ahead and create our streams for us. We can confirm as much by going to the streams page, and we can see here that there are two things that are deploying. Their state should transition to deployed anytime now. Right now, deployment just means starting a Java process using a jar on our local machine. So we've got two streams, which are in turn composed of several different components. So even though we've got two streams here, this may turn into 5 or 6 or 4 or 5 or whatever different Java processes. I guess I'd have to parse that to figure it out. So they're both deployed. We can see exactly how many have been deployed by going to the runtime. And here we can see that, if we did PSAUX, we would see 4 processes 4 Java processes that we don't recognize. That would be these 4 processes, these 4 things. And if we click on these, we can see that this component is running. It has a standard error log and a standard out log, and we can see the URL it's available at and the working directory in which it's running. And the standard error and standard out are particularly useful for the log component because, after all, it's going to log the data that we see. So let's grab that URL there, hit close, and let's set the stage. Okay, so we've got an FTP server running on the local machine in the background. We've got a desktop here, an input directory, nothing there. Let's monitor the logs for this component here. So it's up and running. You can see the log sync Rabbit application is up and running for us. And what we're going to do is we're going to write some data in a text file, and then write that text file to the input directory. So I'll just write some names in lowercase. So we'll say Mark and Josh and Mark and Dave and Michael and Ilya and Eric and so on. Save the names here to the input directory, or names.txt. These are all in lowercase. Save it there to in. We've got nothing in the WS directory, or the FTP WS directory, so as soon as we save this, we should be able to go to the FTP directory and confirm that everything has been written in uppercase. So desktop, FTP, WS. Now there's all the files, but they don't have any new lines, so let's go to the desktop FTP WS directory and find each one ending in .txt. We'll loop over each one, cat them, and then echo a new line, and then be done with it. So there we are. There's all the names, but now they're uppercase. So this is one way by which we can create complex flows, is to use that visual design time tool. And that's very, very useful because you can interrogate the state of the applications, you can manage them, and so on. The same is true for tasks. Really, you just register a Spring Batch job in a jar, just like you would our components here. You can register an application, and it could be of type task, as we can see here, right? Or anything that can implement application runner or command line runner, that's also a task. This is one way to interrogate and work with the server. Another is to use the Dataflow Shell. So I've thus far been creating things using that visual design tool because I think that's a very nice way to work. But there's also a Dataflow Shell that you can download, for example, on mavenrepo.com or search.maven.org. It is here. The latest version is 1.01 release as of this date, but check back whenever you want. I happen to have the jar here, so I can say java-jar shell.jar. There we are. It's going to connect by default to 93, which is where the server is running, but you can specify where it should find everything. If I do app list, I can see all of the components that are registered here out of the box, ready to use. I can see the streams, right? The same information, all of that same information that we used and interrogated and worked with in the Dataflow sort of server itself is available from the shell, and anybody can point their shell to an instance of the server, even if you don't have access to the server itself directly. All right. With this, we've looked ever so briefly at how to create really interesting sort of complex solutions. We've looked at how you can build upon what we learned in our videos looking at Spring Cloud Dataflow and Spring Cloud Stream and Spring integration to build really, really sort of complex stream processing solutions for potentially endless amounts of data or batch or task-centric kinds of workloads. Because Spring Cloud Dataflow manages the state, we have an easy way to monitor and administer these jobs, these tasks. We can launch tasks, we can launch jobs in an easy to understand way, and it's very easy to see. It's very easy to see how we could build more complex solutions by composing these little Lego bricks. Right? This is not even code. What I've done here is really, you could build complex solutions for anything. One use case that I quite like is remediation. Right? Imagine building a flow that looked at the logs coming off of Cloud Foundry, for example. You can register the Cloud Foundry log aggregator source, and then you could write a processor that keeps only the data that matches a certain format, and then write take that data and then write it out to a sink. In this case, a field value counter. So you could actually keep a counter in Redis for every occurrence of a message coming from that processor that basically does grep. So now you have an easy way to based on that counter. In another flow, you could say, okay, if that counter becomes greater than 10, then maybe we should send an email, or somebody should restart a server, or something, right? And it's easy to pull that stuff together very, very declaratively, right? And you can describe ad hoc flows. So even if you haven't thought of every possible integration flow, you can sort of rework and create new ones on the fly. All right, thank you very much. See you in the next video.